Assalamualaikum and good afternoon. So in this question, the large 600-meter long, 100 meters diameter, cigar-shaped dirigible is planned for cruise for retired engineers. As a first estimate, the drag is calculated assuming it to be a flat plate with zero pressure gradient, with the drag on the nose and rear are neglected. Estimate the power required of each of four engines if it is cruised at 15 meter per second. Estimate payload if one half of its volume is filled with helium. And its engine, equipment, and structure have a mass of 1.2 times 10 to the power of 6 kilogram here. Okay, so in this situation, we need to calculate the power. So you know power is actually the function of drag force times velocity. So we need to calculate the drag force. Okay, how to estimate this situation? Okay, so we take the fluid is an air. So the temperature is, let's say we take around 20 degrees Celsius. So first we check the Reynolds number. So from this equation, we could check the Reynolds number. So we take the density of air at 20 degrees Celsius. Here is 1.204. So we take 1.204 here. So we calculate, we found that it is the Reynolds number, it is around 5.98 times 10 to the power of 8. So we assume that it is a fully turbulent boundary layer. So after we know the value of Reynolds number here, we could calculate by using this one. So because this is 5.98 times 10 to the power of 8, so means that actually it is around this area. So means that we could calculate the value, we could estimate the turbulent boundary layer by having 1 over 9 here. So means that it's become y over delta to the power of 1 over 9 according to the Reynolds number range here. So and then you do your calculation, the delta, the CD using the von Karman equation and so on. And finally, you could get the value of CD is around 0.073 over Reynolds number to the power of 1 over 5. And if you substitute the value of Reynolds number here, you will get it is around 0.001282. So you could calculate the drag force by using this equation, and you will get it is around 32,732 Newton. So we could calculate the total power by using this equation. So we multiply the drag force and the velocity. So we get it is around 490,980 watt. So this actually power comes from 4 engines. So if we want to calculate power for one engine, so it is around 122,745 watt per engine. So and then we need to calculate the payload. So payload is the object or the entity which is being carried by an aircraft or launch vehicle. Sometimes payload also refers to the carrying capacity of an aircraft or launch vehicle, usually measured in terms of weight. So in the simple word here, payload is actually the extra load that we could carry on our vehicle after deduct all the parameters. So first, what we need to think is this is an helium gas actually. So helium, it has characteristic to float, to go up and to floating in air. So we could have the free body diagram like this. For example, we have a force of buoyancy actually. So because in a normal situation, we found that this balloon, okay, will go up. So and this balloon, it is because of the helium here. So and then it needs to be subtract with the weight of air, because you know if we fill balloon with only an air, so it's cannot going up. So means the air is actually the mass of air is actually one of the burden in this situation. So if we could imagine this situation, so we could have calculation of force of buoyancy plus weight of helium. Okay, because these both parameter will help this object floating going up, and it must equal to weight of air here, because the weight of air here is usually going down. So and then so we could use the total force of buoyancy, because if we don't have balance of force of buoyancy here, means that if the capacity of helium here is just equal to the weight of air, so means the helium here maybe cannot floating this, cannot float this object. So for sure the helium here has an extra energy that we call as force of buoyancy actually. So and then we could say that the force of buoyancy, okay, is actually need to overcome the weight of the airplane, mean the weight of the structure of this object plus an extra weight that we could put in the object. So this is actually the payload, mean an extra weight that we could put in our airplane to make sure that it can still floating in atmospheric condition. So how to calculate the weight here? So I simplify it here. We know the weight is actually the rho GV. So mean the rho G here, uh, rho and volume here will give you mass, and then we multiply with gravity to get the weight. So and then this is the density of air, 1.204. So you know the gravity 9.81, and then we need to so this is the volume of the shape of the airplane, and we need to divide into 2, because this is the from the question it says that if 1/2 of its volume is filled with helium, so means we need to divide by 2, because half is helium and another half is air. So that's why we divide into 2 here. So and then if we calculate, so we get it is around 27 mega Newton weight here. So and then we could calculate the weight of helium, so by changing the density of helium. So you could see here the density of helium is, it is very light, so it is around 0.1634. So we multiply with the gravity and also with the volume. So please remember we need to divide into half. So and then we got it is around 3.7 mega Newton. So and then the weight of airplane here is mass times gravity. So the mass here is given in the question, and then you multiply with gravity 9.81. So you will get around 11.7 mega Newton. And then we could calculate the payload here according to this equation. So we could find that it is around 12.28 mega Newton. So mean this is the total weight that can be carried by the airplane, okay, because this is the extra weight that can be loading into the airplane.